Okay, so let's take a look at this specific type of thing where we're going to be looking for what's called a particular solution. Okay, so remember, so we're doing this indefinite integration. So when we're finding this antiderivative, we always have this plus c at the end. So the plus c always appears. But sometimes we must solve for this c to find a specific constant that works in our answer. So this just says any constant works. But sometimes if we have more information, then it's not true that any constant works. Maybe there's only one constant that's going to work for us. So by doing this process of finding the specific constant that works in the context of our problem, this is called finding the particular solution. So if we take a look at an example, find the particular solution of g of x is equal to the integral of 6x squared plus 3 dx, where g of negative 1 is equal to 6. So notice this integral over here, I could find this general solution, this general indefinite integration. But I have this additional piece of information that says g of negative 1 equals 6. So we'll see how does that get used. So if we look at this integral, let's work with this. So if g of x is equal to the integral of 6x squared plus 3 dx, well, again, we think about our rules. I have to add 1 to the power of x and divide by that power. So I have 6 times x cubed divided by 3. So the constant stays in front. I add 1 to the power to get to the third. I divide by that 3. And then here, if I have a constant, the integral of that becomes 3x. You could think about almost the same type of rule, right? That the power of x in this case is x to the 0. So you add 1 to the power of x, so that becomes x to the 1. You divide by 1, and you just get x. So the same rules apply, but it might be easier to just remember this one. And I always have this plus c. So this is my function g of x. Now, we could simplify this a little bit, and this would be 2x cubed plus 3x plus c. So my function must have this meaty part of it, and then there's plus a constant. So any constant seems to work. But not every constant works, because I need to have this restriction be true. If I plug in x equals negative 1 into this, it doesn't always equal 6 if c is allowed to be anything. So let's see what happens if I plug in negative 1. So when x is equal to negative 1, I have 6 is going to be equal to g of negative 1. So I plug this in. So I have 2 times negative 1 cubed plus 3 times negative 1 plus a constant. So this becomes negative 2 minus 3 plus c, so I have minus 5 plus c. So this g of negative 1, we know that equals 6. That means that 6 is equal to negative 5 plus c. So only one c value is going to work. So obviously by adding 5, we see that c is equal to 11. So I have found the specific c, and I'm going to plug that back in. So the g of x that works, so this particular solution is going to be 2x cubed plus 3x plus 11. And so that is how we find a particular solution, is we first do the integration. After we do the integration, we get the plus c. Then we find that c by using this, we call this an initial condition, that something is true about my original function, and I'm going to check that everything is good here by finding that c.